let's do magnetic fields, magnetic force on a current carrying conductor 1. A current is carried by a straight conductor in a magnetic field of 1.3 Tesla. The conductor is perpendicular to the magnetic field. The conductor is 2.1 meters long and the magnetic field exerts a 1.5 Newton force on it. Part A, calculate the current in the conductor, and B, what is the angle between the conductor and the magnetic field when the magnetic force is at a maximum? Explain your reasoning. So let's look for the current in the conductor first. So for a current carrying conductor, the magnetic force is actually given by ILB sine theta. Now for those of you who watched the previous couple of videos, you would have seen I talked a lot about something called cross product, how you multiply vectors. Now, if you are very savvy, you probably noticed that, you know what, I've got another sine theta here, and hey, current and magnetic field are vectors, and of course, magnetic force. So this is actually the same thing as saying IL cross B, okay? Now, the L is just there, it's getting multiplied, it's L is just a number. But the vectors that are getting crossed are I and B, so the angle theta is the angle between the current and the magnetic field. Now we're told in the question the conductor in which the current is flowing is perpendicular, right? So that means theta is equal to 90 degrees, so therefore sine of theta is at a max. So let's stick with the original formula for now. So FB is equal to ILB times 1, right? Because sine of 90 degrees is 1. Okay, so do we have our current? The current is, we have to find the current. So current. So to isolate for I, we have to divide left and right side by LB. So FB divided by LB equals I. So plug in your numbers. So I is equal to, so FB, the force that's exerted is 1.5 newtons. And the length of the wire is 2.1 meters long. And the magnitude of the magnetic field is 1.3 Tesla. So you just simply have to punch this in your calculator and see what you get. And when you do, you get the current to be 0.55 amperes. Okay? So there's the answer for part A. Now for B, what is the angle between the conductor and the magnetic field when the magnetic force is at a maximum? Explain your reasoning. Okay, so I actually did explain this in a previous video, but here I'm going to do it again. This is what controls how big, the ratio for the magnetic field, how big it's going to be. So if you remember the graph of sine theta versus theta, it goes between -1 and 1. So if you remember the graph of sine theta, it oscillates between -1 and 1. Okay, so it has a minimum value of -1, a maximum value of 1. So here we have 2 pi, pi, 3 pi over 2, and then pi over 2, right? Now notice, because sine theta goes between -1 and 1, or rather if you look at the absolute value between 0 and 1, therefore the maximum value this takes on is 1, therefore the maximum magnetic force you can have is just whatever you get from ILB, I times L times B. That's the biggest number you can get. If theta is anything other than pi over 2, 90 degrees, which gives you the maximum sine theta value of 1. If you have any other angle here, you're going to get a fraction of sine theta. Like, for example, 0.45. If you multiply whatever this is equal to times 0.45, you're only going to get 45% of this size, whatever this was. So it's going to be smaller. So the maximum magnetic force you can have is when theta is equal to 90 degrees. And that is simply due to the nature of how the graph looks. So guys, that's it for this problem. I hope you enjoyed it. Stay tuned next time for video 182, magnetic force on a current carrying conductor 2.